Alright, for this section, we're in section 5, topic 8, which is on page 149. So turn in your workbook there with me. And we're going to do part of this section. We're not going to do every single problem because we're going to save some of them for tomorrow when we talk more in depth on proofs. Okay, so the first thing we're going to look at is it says, by definition, and blank blank is a triangle with two equal sides. We talked about this earlier. This is an isosceles triangle. Okay, so we have the triangle UVA here, and it says that side UV is equivalent to side VA. So they are congruent. That means that they are the same length. Okay, so one way that we can show that these angles are congruent is by the following. So say we draw an angle bisector here between V. Okay, well when we draw this angle bisector, well it splits this angle in half, so these two would be congruent. Okay, and then we have a common side that they both share. So we don't know that those are congruent yet, we're just trying to show. So now we have two sides, the angle, and then another side. So we have angle, not angle, we have side, angle, side, that shows that they are congruent. Okay, so if these two triangles are congruent, then angle U and angle A must also be congruent. Okay, so more generally, if we have an isosceles triangle, okay, I'm going to draw another one. So say this is an isosceles triangle where this side is equal to this side. Then it is always the case that these two angles at the base, so that are across from the equal sides, are also congruent. And we will generalize this in a minute. So now let's flip over to the next page. Alright, as I was saying, we're going to flip over to page 150, and here we're going to look at the first problem there. So it says, consider the diagram below. Well, this one looks like yarn that's tangled up into a knot. And it says, for each of the following congruence statements, name the isosceles triangle and the pair of congruent angles for the triangle based off of the diagram above. So we're going to do most of these together, and then I'll leave a couple for you to practice on. So looking first at A, we have CD is congruent to BD. So where is CD? So that's right here. Let's draw that straight. CD is congruent to BD. Okay, so this is congruent to this. So what would be our isosceles triangle? Well, it would be triangle BDC. And which angles are going to be congruent? Well, this one opposite would be here. Opposite of this one would be here. So what would our angles be? Well, it's be angle CBD is congruent to angle DCB. Like so. Okay, let's go down to part B. I'm going to switch colors on y'all so that it'll show up better. So it says that side FJ, okay, FJ is right here, is congruent to GJ. Okay, so we have those two sides that are congruent. So our isosceles triangle would be right here. Well, it'd be triangle FJG. And which angles are going to be congruent? Well, we have the angle that's across from this side JG, which would be this angle at F, so JFG. And what's it going to be congruent to? Well, the angle opposite of this side, FJ, which is over here, FGJ. Okay, and then next let's look at C. So it says AH is congruent to EH. So AH is right here, and then EH. Okay, so if those two sides are congruent, what angles are going to be congruent? Well, the ones opposite those sides. So what's our triangle? Well, it's AHE. And the angles that are congruent would be HAE is congruent to HEA. Like so. Alright, I want you to try part D and E on your own, doing the exact same thing. You're going to look at what they're giving you. These two sides are congruent. Find that triangle that's an isosceles, and then you want to write which angles are congruent. Do that for part D and part E, just so you can practice some on your own as well. Alright, next let's look at that theorem that's at the bottom of the page. Then we'll scroll up so you can see it. So it says base angle theorem and its converse. So the base angle theorem states that if two sides in a triangle are congruent, then the angles opposite to these sides are also congruent. Okay? The converse of this statement is also true. Remember, our converse is just where we switch the order. So the converse of this statement would be that if two angles of a triangle are congruent, then the sides opposite to these angles are also congruent. Okay? So basically this base angle theorem is saying that if we have two sides that are congruent, then the whole triangle, then those angles, not the whole triangle, those two base angles would also be congruent. Or vice versa, if we had those two base angles, then the two sides are going to be congruent. Alright, we're going to skip number 2 for today. We'll do that one tomorrow. And next we're going to look at problem 3, which is on page 151. So it says, consider the figure below. You have Q, R, M, N, and P. And it says that PQ is equal to PR, and that MN and QR are parallel. And it wants us to prove that PM is equal to PN. Okay, so we're going to be filling in the proof here at the bottom. So the first statement they list us is PQ equal to PR. Well, where did that come from? Well, it came from right up here in our given. So it is our given. Next, it tells us that triangle PQR is an isosceles. Why do we know that triangle PQR is an isosceles? Because we have that two sides are congruent or equal, and this is by definition of isosceles triangles. So what does that tell us using the base angle theorem? Well, remember our base angle theorem says if we have two sides that are congruent, then their two base angles are also congruent. So that means that angle Q is congruent to angle R. Okay. Then it says that MN is parallel to QR. Well, this was from our given up here. And now we're going to use that information. So it says that angle NMP, so let's label those. I'll use blue this time. So NMP is here, and RQP, well that's right here, are congruent. And then it says that angle MNP is congruent to QRP. Right there. Okay, so what is this by? Well, remember these are parallel lines, so if we extend those, and then we extend these sides of our triangle, what does this look like? Well, we have parallel lines cut by transversal. So what is these type of angle relationships called? When we have an angle, skip one, have another one, they're on the same side. These are by corresponding angles. So what would use our transitive property? Remember, transitive would say that the same would be that we have one thing is congruent to another thing, then they're both going to be equal to each other. So let's look at that. So using our transitive property, we can have that angle NMP is congruent to the angle MNP, and this is by our transitive property. So we have NMP is congruent to RQP, which is the same one as right here, which is then congruent to this one, which is right here. So this one is congruent. Does everybody follow that? So let's go over that a little bit slower. So we have the angle MNP is congruent to angle RQP, which from step 3, we have that is congruent to angle QRP. By the other part of 5, we have the angle QRP is congruent to angle MNP. So thus, if we cut out what's in the middle, we have that these two things are congruent. That's what we did. Then next we're looking at 7. It says definition of congruence. Well, if two things are congruent, then their measurement is equal. So the measurement of angle NMP is equal to the measurement of angle MNP. Okay, then lastly we have that PM is equal to PN. Okay, well this is going to be by the converse of our base angle theorem that we just went over. Okay, so PM is equal to PN. So this part right here is equal to this part right here. So we have just proven that PM is equal to PN, just like it asked us to. So we are good.